this time. That's good. Perfect. All right, so as I was saying, when we're going through this paper, the first question is multiple choice, and the second question is match column A with column B. We'll come back to that if we have time, but I'm sure you guys realize by now, ChatGPT is an amazing resource for studying most of these questions, probably all of them actually. If you put them into ChatGPT, it'll give you the correct answer. So yes, if we don't get to finish all these things, I mean, ChatGPT is very useful. It gives you detailed explanations. It tells you how to do things. So we live in an amazing time. It's very useful, right? I should just point out with 1.1, I was browsing through this and I can see probably a mistake here already. So let's just go through 1.1 first. If the general term of a sequence is given by this formula here, the first term of the sequence is what? Right, so usually you would plug in n equals to 0 into this formula to get the first term. If I plug n equals to 0, I get 0 minus 1 over 0 plus 1 is equal to minus 1 over plus 1. Nope, it's plus 1 at the bottom, which gives us minus 1. That should be the answer, but that's not an option here. And I suspect what they did is they plugged n equals to 1 instead of n equals to 0. Because there was a portion in the notes at some point, I think it said you start with 0, and at some point it said you start with 1. So that was a bit of ambiguity here, but it's clear to us that you must start from 0 based on all the examples that they do. So if you start from 0, you get this as an answer, and that's not an option. So let's just note that's a mistake that they made here. All right, that's 1.1. Most of the other things seemed okay to me. I didn't go through them all in full detail, but okay, and here this is just sort of the theory part of it. Again, that we come back to at the end if we have time. Let's start with 3.1, evaluate an expression. So again, this is just board math stuff, guys. There's not much more I can teach here. Of course, just always use the trick of first putting this into your calculator, get an answer, and then you know what your final answer should be. So work towards that using board math. Brackets of blah, 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 right? You know the story. Okay, again, we'll come back to these easier ones if we have time. 3.2 is where the mistakes start. So I should do this one. So it says evaluate the expression, which is an absolute value expression, if m is equal to 1/4. Right? So what I see people doing here is solving for m. Please don't solve for m. That is more work than you need to do. You simply take the expression they give you and plug in the given value of m. Right? They give it to us already, so we don't have to solve for anything. M is 1/4, so I just substitute 1/4 here for m. And then it's pretty straightforward after this, but let's just show the steps anyway. So on the left-hand side, we have 3 times 1/4 in the absolute value. That's going to be, if you guys remember, this is the same as 3 over 1 times 1/4. 3 and 3 over 1 are the same thing. So we multiply the top numbers and the bottom numbers to get an answer. 3 times 1 is 3. 1 times 4 is 4. So 3 times 1/4 is 3 over 4. And then you get minus 7 over 5 here. And I'm sure they're going to want to see common denominators and all that stuff. So again, I'll do this relatively quickly. The denominator at the bottom is going to be given by 5 times 4. So that gives us 20. Now on the left here, to convert 4 to 20, right, I'm looking at the bottom. To convert 4 to 20, I multiplied the 4 by 5. Right, so I multiplied this by 5. That means I must do the same on top. So that top part becomes 15. And the right-hand side, or the right part of this equation, to turn the 5 into 20, I multiplied it by 4. So that means I must do the same on top, right? And then you get 7 times 4, which we will write up here as 28. And remember, all this is still in an absolute value. Okay, now 15 times 28, this is where I don't shine, so I'm going to put that in the calculator just to be safe. That's minus 13 on top of 20, still in an absolute value. And this is where people often lose marks. Now from here, we can just simplify this. absolute values essentially get rid of negative signs. It gives you a magnitude only without a direction on the number line. So negative and positive becomes irrelevant, and this simply becomes 13 over 20. So this is what we need to get. Right? But please make sure you're not at this step here eliminating negative signs. Some people do that and they write 15 plus 28. That wouldn't be correct. That wouldn't work. Only at the end, in the last step, can you eliminate the negative sign. All right. Okay, so that's 3.2. I should always maybe go back and check for questions after everything that I've done. Check the chat. Excuse me, someone is burning masala in this house. The scent is coming to my room. But I think I'll survive. Okay. All right, everyone seems good so far. Just realized this is being recorded and I'm saying all these stupid things, but anyway, what can you do? 3.3, write this in scientific notation. This mistakes often happen. But since this is all recorded, I can delete this and make space. That's okay. So writing something in scientific notation, you need to be using exponential rules all the way, right? They may not say that, but that's always implied that that's what needs to happen. So use exponential rules all the way. Don't simply put this number into the calculator and get some big number and then convert to scientific notation. You will lose a lot of marks for that. So what you need to do, what we need to see here is, can I change this thickness a little bit? That's too much. Okay, that's fine. So what we need to do is, I'll write the number 5, no, it's not 5, so it's 5.2. 5.2 times 10 to the minus 14. 4 times 10 to the 9. Now to simplify this, remember this is the same. These are all products here. So there's no addition, there's no subtraction. So when it's all multiplication, this is technically the same as writing 5.2 times 10 to the minus 14 times 4 times 10 to the 9. It's nice to write it like this because then you avoid the temptation of using FOIL to open these brackets out because you can't do that with multiplication. You can only do that if there's addition in the brackets and multiplication on the outside of the brackets, right? Which is usually the case. But here that's not the case. All multiplication, so we don't FOIL anything out. So that means this is all multiplication, and multiplication commutes, so the order doesn't matter. We can move things around however we please. So anything which is not a base 10 number, I will move to the left. Anything which is a base 10 number, I move to the right. And now we can simply use exponential rules. The 5.2 and the 4 on the left, we can just simplify that using calculators or using our brain if you are sharper than me. Right, that is 20.8. That's the 5.2 times 4. And on this side here, we have 10. The minus 14, which is a power, and the 9 will simply add together because 10 is a common base. Right? So from here, it becomes straightforward. 20.2 times 10 to the, so minus 14 plus 9 is going to give us something negative. Negative 5, is it? Because we're going, yeah, negative 5. Okay, is that right? Yes, that is right. And then this is where we think we complete, but we're not, because remember, scientific notation means you need some number between, what is it, between 0 and 10 over here. Or between 1 and 10. Yes, you need a number between 1 and 10 here, and this is not between 1 and 10. So we have to make it into a number between 1 and 10. Right? So we can do this in one step or we can increment it. So let's see, if we do this in one step, 20.8, we can convert it to 2.08 times 10 to the power. Now the minus 5 must change. We've moved the decimal 1 point to the left. This always confuses me, so let me just think for a second. We've turned 20 into a smaller number, so that means it needs to be represented by some bigger base. So it should be 10 to the 1. So we need to move this 5 1 point backwards. It becomes minus 4. But if you're ever unsure about this, if you go back to a previous video where we did the section, I showed you guys a step in between if you're not sure. And a way to check your answer is to just enter this whole number into the calculator and enter this number into the calculator and see if you get the same thing, right? Maybe we should do that now. I'm putting 20.8 times 10 to the minus 5 in my calculator, and I'll tell you what I get as an output. If this thing will just let me do this, I get, okay, let's just write it here. If I put this into the calculator, this one on top, I get 0.123208. Now let's check the bottom one. Does it correspond? So that is 2.08. Let's change that. 2.08 times 10 to the negative 4. And I'm getting 0.000208, right? Same thing. So we're happy about that. Right? I'm only going over that part because that's a common mistake as well. Even I often make a mistake there, but we need to know if it's a step that has a possibility to make a mistake, we need methods to just do it slowly and be careful. So you guys will be okay here. Don't worry about it. Just be aware that you have to be a bit slower there. Okay, unless you're one of those guys that can do it quickly, then we're okay. All right, 4.1, do solve by method of factorization, describe the roots. Okay, you see things like this, they make mistakes, and they mentioned to us afterward that this was a mistake. Describe the roots of this equation, but it was not part of our syllabus. So when I mark this, I imagine that wasn't there, right? You just need to find the roots. We can describe it for fun, but yeah. All right, so what method should we use here? I mean, this one you can do by looking at it, or you can use the R and S method, which I'm not going to go over in detail here. But let's see, what if I wrote this as x plus 3 and another x plus 3? I'm sure that should work, is equal to 0. All right, just put my phone on silent. Okay, so then once you get to this point, because it's equal to 0, we use the principle of zero product. And then we can write this as each individual product equal to 0. Right, you guys probably know the story by now. But we don't actually need to do that because we notice the root is repeated. So we only need to do this once. We can just write this in one go as x plus 3 squared equals to 0. Square root both sides and get x plus 3 is equal to 0. So we only need to do it one time if the root is repeated. Move the 3 to the other side and get x equals to minus 3. And that's the answer. So the hardest part here is really factorizing. And again, if you're not sure, just go back to the R and S method section. It shows you how to do that there. All right, so that's that. Let's quickly jump into the chat and see if everyone's okay. Do we get a formula sheet? I don't think, I just feel, yeah, I don't think we get a formula sheet here. I don't think, I mean, we have an exam paper here. We can check if there's anything at the end. I doubt it. Yeah, there's nothing here. So those little formulas, unfortunately, we have to memorize them. And I hate memorizing, but yeah, that's the thing. Okay. 4.2, I'm just looking at this and wondering why it's worth 7 marks. Something off here. Okay, I think I can see a slight trick here, so let's do it. 4.2, we can break up the roots. Square root of 25, square root x to the 4, square root y squared. Right, these are all multiplied together. So a square root is essentially in the realm of working with powers. So you can operate the way you do with powers and you can distribute it to all the terms inside. Square root 25, we know that's 5, so we're happy with that. X to the 4, let's rewrite that as, let me write it like this, x to the 4 raised to the power half. All right, and y squared, so we could simplify this in one go, but just to be consistent, let me do it like this as well. Y squared to the power half, that will be equal to 5. X 4 to the power half is 4 over 2, right? Because that's essentially 4 multiplied by a half. The same is true with the y. This becomes y to the power 2 over 2. Right, that's what happens there. And then the 5 is still as it is. X to the power 4 over 2 is just 2. Here we have to be careful. Y to the 2 over 2 becomes absolute value of y, not just y. And that's because of the rule that if you have, let me see how I should write this now. let's write it like this. If you have the nth root of something to the power n, that is equal to x if n is odd, right? Or that is equal to absolute value of x if n is even. This is very bad writing, but you guys can hear what I'm saying. So here we have an even n. It's essentially the same situation with an even n. I mean, you look at it from the start here. See what I'm circling right here? That's a square root on the outside and a squared variable on the inside. So that's why we end up getting an absolute value because n is even. Okay, so that's another one to look out for. That's probably why it's worth 7 marks. And that's still a lot, but anyway. Okay, inequality. Let's see. Let's just see how many more important things we got. Okay, truth tables was recently, so if we don't get to that, I'm not going to be too unhappy. It was the last thing we did, I think. Okay. 3. Let's take a rain check on 4.3 because 4.4 is going to be a one that people make a lot of mistakes with. Let's do it in red because it's important. Okay, add the complex number 3 minus 2i to the complex number 4 plus 3i. Multiply the answer by the complex number 6i and write your final answer in the form a plus bi, where a and b are real numbers. So it all sounds very intimidating, but it's just a recipe to follow. And I don't know if it's all going to fit here. I might need to move to another place. Okay, let's see if we can. Where's the snipping tool? Let's move this to something else. Can I just type here, please? Uh, okay, I'm just going to have to open up this laptop from a tablet mode to laptop and find the thing like a normal person. Snipping tool, there's it here. Let's take this and move that side. Take the marks as well to remind us. Copy from there. Next here. Okay, there we go. Now we can work with this. Okay. Add the complex number 3 minus 2i. We'll start with the first sentence here. Add the complex number 3 minus 2i to the complex number 4 plus 3i. All right, so essentially add these two is what it's saying. So let's keep them in brackets and add them. We don't need the brackets, but just to be careful. Then multiply the answer by the complex number 6i. So whatever we get here, the bracket will be multiplied by 6i. And then write your final answer in the form a plus bi. It's not so bad. So this is really what we have to work out, and then write it in complex form, a plus bi. All right, so let's operate within the brackets first. 3 minus 2i. A plus sign doesn't change anything, so it's just going to be plus 4 plus 3i. If it was a minus, that would be a different case. We'd have to be careful, but it's not, so we are okay. So what we can do now is just keep the numbers which don't have imaginary parts, just keep them on one side. 3 plus 4 on this side, and then minus 2i plus 3i on this side, 6i on the outside. 3 plus 4 is going to give us 7 on this side, and then minus 2 plus 3 is going to give us positive 1. Right, so we can write positive 1i or just positive I. Right, the 1 is implied if we don't write it in front of a variable or an I. 7 plus I. Okay, so that's the thing, and then the bracket is still there, 6i on the outside. Okay, so then from here we can use FOIL, or is that what we call it? Yeah, to distribute the 6 into the 6i into the bracket. So the 6 times 7 is going to give us 42, and there's still an I there, so 42i. That's that part. Then distributing here, we will get 6i squared because there are two i's. Right, and that becomes 42i. Remember, I squared is the same as -1. You don't have to really memorize that. The thing you have to memorize is that I is equal to square root -1. So you can see if you square it, you just get -1. Right, so this is what we need to apply here. So let me go back to the thing. We got plus 6 and I squared we've shown is -1. So that means we get 42i minus 6. So this is almost in the form a plus bi. But to be very careful with that, we will write this as -6 plus 42i. And we can see that is the form a plus bi, where a is equal to -6 and b is equal to 42. Okay, so you don't have to write all that at the bottom. You just need to write up until here as your final answer. Okay, so that was the big one. 10 marks for all of the stuff here. Let's just check how the people are coping. Oh, Creel, that's a tough one. I don't know. I don't know. 2022 was quite nicely picking this one, but I'm going to give you guys a few. Just browse through as many as you can. Yeah. Okay, so the lecturer sets the paper so we can nudge you guys in the right direction, but here there's no such thing. Okay, and again, I'm saying all this on video. Why am I doing that? 5.1. All right, so this is one of those things that I hope I remember. Set theory. Yep. Okay, so we're given a universal set, U is equal to 1, 2, 3, 4, all the way up until 10. We're given the set A, B, and C, and we're asked to find some results of set operations. Okay, so 5.1.1, I'm hoping you guys remember this stuff, and I'm hoping I do as well. A union B is what we need to find, which is just combining A and B together. So A union B is equal to, can I zoom in a bit here? Yeah. Is equal to whatever A is, which is just 1, 2, 3, 4, 5, combined with whatever B is, which is 2, 4, 6. So I could just write 2, 4, 6 here if you wanted to, but remember repeats don't matter. We don't, this 2 is repeated here, so essentially we don't need to write it 2 times. So I could just write this as 1, 2, 3, 4, 5, and then just write whatever's in B, but not what is already here. So 4 is also repeated. 6 is the only new thing. So that would be your answer for 2 marks. You don't have to show this step here necessary, but if you want to, go ahead. Sometimes it helps. All right, find the set difference A exclude B. That's the next question. So A exclude B is basically just take whatever is in A and subtract from it. I use the word subtract loosely, but eliminate whatever is in B. So again, I write it like this in a very loose way, just so we can memorize it. I recommend not showing the step I'm about to write like this, but let me start by writing A, 1, 2, 3, 4, 5. And I'm going to say minus, but I'm going to put quotes around it because it's not really minus, right? You don't subtract in set theory, but minus B, which is 2, 4, 6, right? So again, if you're using this step, maybe write it on the side or something, but don't let it be a part of your main thing. So let's write the original set by eliminating whatever's in B. 1 is fine. 2 is not fine because we eliminated it. 3 is fine. 4 is not fine because we took it out. And 5 is okay. So that's what you would do. And again, don't write the step unless you show it on the sideline or something.
So then what do we do about the 6 in B? Does it just fall away or?
Yeah, good point. Yeah, it just doesn't contribute. Yeah.
Okay, no, perfect. Thank you.
Okay, no problem. Yeah, guys, if you have questions as I'm going, please just interrupt me. It's the only way I know something's up. All right, perfect.
I have a question, sir.
Yes.
Do we get formula sheets in the exam?
No, it doesn't look like you would. If I'm going by the past papers, you haven't usually been given formula sheets. Actually, I
So
shouldn't
we'll
say
have to
usually.
memorize the cardinality of a union formula.
Yes, you have to memorize all that stuff.
Okay, thank you.
Okay, no problem. Sorry to be the bearer of bad news, but yeah. Okay. Find the set 3.1.3, find the set A union C. No, sorry, not union. A intersect C is what this is. So this is an intersection, which means we find common elements between A and C. A and C. I'm trying to sound that without sounding like it's a political party. Find the set A intersect C. Okay, so what's common between A and C? That's all we need to write here. What is common? I see 1 is common between both of these, 3 is common, and 5 is common. So the answer happens to just be C. You don't have to write that, but yeah, we notice it so we can write it. Okay, Cartesian product between C and B. And the Cartesian product is just a bit of a headache thing where you need to be a bit careful. We have space to do this here. Let me do it at the bottom. C cross B is going to be, it's going to be some big set where we take elements from C first in the Cartesian product. So the first thing I see in C is 1. The first thing I see in B is 2. All right, so we start like that. Then, let's see, which order do we go in here? Because we're starting with C. Then I continue with the 1 from C. I'm using the first one from C for everything in B. Okay, so C, this is the first element in C, and then I cycle through all in B. So in B we have 2, then we have 4, then we have 6. All right, so that's for the first element of C. Then for the second element of C, which is 3, I do the same thing with B. I just cycle through all of them. 2, 4, and 6. Right, and then the same thing for the last element of C, which is a 5. I write the 5, then I cycle through B. 2, 4, and 6. And that's it. That's all you got to do for 4 marks. Right, you just have to sort of memorize that method. All right, so that's 5.1.4. Yeah, I hope these people don't give brain teaser questions here, or you guys have to watch me struggle. What's 5.2? Okay, we can do this one. Let's just quickly check up on the people in the chat. Okay, yeah. All right, so let's note some space here for 5.2. So imagine this being too difficult. They've given us a closed formula here, Tn, and what do they want us to do? They want us to find T6 minus T2. Now this is not really so bad. We just need to plug n into this thing to get T6 and then plug n in to get T2. So let's do them one at a time. T6 is equal to the formula that I circled, or the formula that I put a square around, but n is equal to 6. Right? That's all this is telling us. So 6 into 6 plus 1 over 2. And again, with these things, you don't really need to show your working. You can just put this into a calculator immediately and get something, which is probably always the safer thing to do. So yeah, let's just do it in one go, 21. And then we need T2, which is going to be 2 into 2 plus 1 over 2, which again, you can just show the answer. So that's going to be what? 3, 6 over 2, which is 3. Yeah, I mean, or you can just cancel the 2's out and get 3, same thing. Okay, so now take T6 minus T2, which is going to be 21 minus 3, and then again, always be safe and use the calculators for this, even if you're unsure, because I will tend between 18, 19 and get confused. So yeah, that's 5. Okay. All right. Yeah, I think we're okay here. Ah, the binary questions. Okay. Let me just check in the chat. How many of you guys want to see these binary questions? Might be a little bit of a while since we've done them. Just put a thumbs up or something if you want to see them. Here we got a few. All right. Let's go for it. Maybe we should copy this to the other place because it needs some space to write here. Put the laptop up, get the snipping tool ready. Take the marks as well, always good to remember. Copy. All right, I hope it gets pasted nicely here. Control V, that's good. Okay, close the laptop up again so we can write. It's been a while since we did this. How do we do this? 6.1, convert 25 from base 10 to base 2. Okay, so this was the one. We just need to use expanded form. What was it? Okay. So is that the thing? No, that's 6.2. For this one here, we need to use, again, there's one of two methods we can use here. The division by 2 method. Yeah. Binary form, right? They say getting it to a base 2 form, which is binary. So let's do the easier method. Although this is the less intuitive method, it's easier to work with. So we take the original number, divide by 2. All right. 25 divided by 2 is going to give us some decimal, which is 12.5. So if you guys remember, anytime you get a remainder, any remainder, it's usually going to be 0.5s, but any remainder, we'll write this as 12 remainder 1. Doesn't matter what your remainder is, we just make it a 1. Okay, so the new number is now 12. We divide it by 2 and then we get 6. So this has no remainder. So this is 6 with a remainder 0. And then we just keep doing this until we end up with 0 at the end. So 6 divided by 2 will give us 3. That's 3 with no remainder. So 3 remainder 0. 3 divided by 2 gives us 1.5. That is 1. It has a remainder, so we just say remainder 1. All right, so then we go 1 divided by 2. That gives us a half, 0.5. So that's 0 with a remainder 1. And then do we stop here? Let's just think, because yeah, if we take 0 divided by 2, it doesn't do anything. So yeah, we stop here. This is the stopping point. And remember, there's ways to double check our answer. But anyway, let me first show you how to write it. If we've forgotten, we always write bottom to top. So we start here and we go upward and we write 11001. So that is 25 in binary. And since it's been a while, I always want to double check these to make sure we're on the right track. I'm going to use the shortcut method, of course. So if I expand this, I can write it as 2 to the power 0. That's represented by this here. Plus 2 to the power 1 doesn't exist. 2 to the power 2 doesn't exist. 2 cubed exists here. And 2 to the 4 exists here. So this will give me converting basically from binary to decimal. If we get 25 back, we know we did the right thing. Yeah, I think 2 to the 4 was 16. Let's just go from this side. 1 plus 8 plus 16. So 16 plus 8 gives us 24. Yeah, plus 1 is 25. Okay, so we're good. So it works out. So our method works, and it's quite a straightforward method as well. For 7 marks, that's not too much of work. All this is not part of the work, that's just checking the answer. So this you don't need. All right, essentially what I've done here that I scratched out is a version of 6.2. Okay, but 6.2, of course, we have to work a bit more because it's 8 marks. So we can't just write a little bit of things. We have to show everything. 6.1 on top, 6.2 at the bottom. We'll start 11101. We have to write this now in expanded form, and then we can use the calculator. So this is essentially going to be, I'm starting from the extreme left. Well, let's see, maybe it's better to start from the right. Let's start from the right, from the extreme right. The first digit I see here is 1, so that's 1 times 2 to the power 0. We always write everything in this form, right? The powers we fill in as we go. The next one here, the 0, is 0 times 2 to the power 1. As you see, these power 2's just increment up by 1 as we go along. The next one right here is 1 times 2 to the power. And I guess you see the pattern here. The next one is 1 times 2 to the power 3. And the last one is 1 to the power 4. Okay, there was only one 0, which is identified here. And that won't contribute anything because 0 times anything is just 0. But I guess we have to write it now to get all the marks because it's 8 marks. Okay, so everything else we can just simplify quickly. The first term here is just 1 times 2 to the 0 is 1, so that doesn't change anything. Right, that's this one here. This one here is 1 times 4, which is just 4. This one here is 1 times 8, which is just 8. And this one here is 1 times 16, which is just 16. Okay, I think this is a good amount of work to show just to get all your marks. And I'm just using the calculator here to save us some time. That will be 29. Okay. Makes sense that it was close to our previous 125 because you see the binary number is very similar. In fact, there's only one extra number, which is, which one is it? 2 squared. Yeah, which is 4. If I add 4 to the previous one, I get 29. Perfect. So it makes sense. All right. If what I just said doesn't make sense, don't worry about that. All you need to do is what I showed you here. Let's take these arrows out, and that's all we need. Okay, this is an important one. Usually comes out every year. So let's just check how the questions are going. Okay. David, yeah. So when they say base 2, it just means binary because binary is base 2. I'm not sure. They're just trying to confuse you with the word. Yeah. And usually they'll use the word decimal for the normal numbers that we use. So that is base 10. Decimal is the normal numbers we use. Base 2 is binary. Yeah. Just trying to catch you guys out as they do. Okay. So we've done well so far. We reached question 7. It's a bit of a big one, but it can be done. Anything else? Okay, let me just see. Do you guys want to do question 7 now, or do you have anything else you'd rather do? Let me go to the chat. Thumbs up for question 7. If you want to do something else, just comment. Okay, we got question 7's going on. Perfect. All right. You guys really want to see me fall down today. Hey, you're making me think a lot. Use my brain here. Okay. So let's do it. Question 7, we need to memorize some stuff, and I should probably show you what we need to memorize. I think I have it in my head because I've just done this section. But if you don't remember it, let me show you what it is. It is from Learning Unit 3, actually, but I've summarized it again in 5 in a table. So it's purple too, so we can't miss it. This one right here, these truth conditions, we need to memorize them. It tells you whether a statement is true or false. See these 5 basic statements here. This one, this guy, all 5 of these. It tells you whether the statement is true or false based on the true or false values of the individual statements, the P and the Q, that make them up. So this we have to memorize, right? So I'm going to go assuming we memorized it, even though we probably didn't yet. That is all right. That's not what I want. Where were we? We're here. No, oh, it's hidden behind this share screen thing. How can I now? Okay, what if I do that? That was stupid. Anyway, let's get started with question 7. Okay, so remember this P, Q, and R that we see here, the first 3 rows is just giving us every possible combination of true and false for the individual statements that make up this big statement at the end, right? So based on that, we need to just work through the rules as we go. So let's do the first one. If P, then Q. That's what this thing here is saying. If P, then Q. And the rule for that is, let's start with blue. This is true if the first statement is false or the second statement is true. You can see that in the rules in the purple table. So in other words, what we need is we need a false here or we need a true here. That's what we need, right? Let me take it out from there. And I'm writing it here because then it makes our life easier. All we need to do is go down the table and match things that we see with the rule above. So what I mean by that is look at row 1. The first row, my Q matches, right? This T matches above. The P doesn't match because for P I have a true here, but the rule says I need a false. So that doesn't match. Okay, so wherever I see a match, I'll just put a circle there. All right. So second row, I see a match for Q again. Third row, I don't see any matches. What I have is opposite to the rows above, so we don't circle anything. Fourth row, I don't see any matches. Fifth row, it's a double match. P matches and Q matches. Sixth row, double match again. Seventh row, P matches. And the eighth row. All right, so once we have that, everywhere we have put a circle, I can claim that my statement is true. So there's a circle, here we have another circle, another one here, another one here, another one here. As long as I have at least one circle, it's good enough to say true. Everything else by default is just false. Okay, so now can we do the same thing for the if Q then R? Of course we can. Change color so we don't confuse ourselves. So as I said, the rule for this is the first part needs to be false and second part needs to be true. So the Q needs to be false and the R needs to be true. So let's follow that train of thought. First row, do I see a match? Yes, the R matches what's above. Second row, do I see a match? No, I don't. Third row, match here and match here, double match. Fourth row, match for the Q. Fifth row, match for the R. Sixth row, nothing. I don't see a match. Gotta stop looking at the blue. The blue can be confusing. Seventh row, see a match for the R and for the Q. And lastly, there is a match for the R. Sorry, for the Q. Okay, so everywhere we have drawn a red circle, the statement is true. So there's one here, we got some here, we got one here, 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 and here. Everything else is just false by default. Okay. Of course, you guys don't have to draw these circles by the P, Q, and R, but to me, it just helps. It just makes things a bit easier. So if you do that, I'm not going to take out marks and stuff. It's okay. Just don't do it in like a dark pen or something. Do it lightly. Oh, yeah. If you guys want to bring colors into the thing, it could be helpful. Not to make it look like a preschool kind of thing, but you guys are welcome to bring in different colored pencils or something if you want to do this. You know, it's helpful. Okay, now the rule that we're looking at is P and Q. This upward triangle sort of looking thing is an and statement. And an and statement is true when both statements that make it up are true at the same time. So where do we see that? Maybe for this, it's helpful to get rid of all these colors. Stop confusing us. We're only looking at P and Q here. So where do I find P and Q both true? I see so in the first row, second row, third row, that's not the case, so false. Fourth row, it's not true. Fifth row, not true. Sixth row, not true. Actually, nothing else is true. So this is true only when both P and Q are true at the same time. Okay. Now, finally, what do we have here? This is a compounding problem. So it means if you got something wrong, then you can't get the last row right. I hate it when they do that. But anyway, I'll give method marks, so it's okay. Let's do one final color here. What looks normal? Let's put, I don't know, green. Why not? Okay, so again, for these if-then statements, the first part needs to be false and the second part needs to be true. So that means the first part is this row right here. That needs to be false. And the second part, if Q then R is here, that needs to be true. So let's go down identifying them and see where we can match things. So first, for the if Q then R, I see a match immediately. First row. Second row, no matches. Third row, double match. Fourth row, double match again. Fifth row, match for the if Q then R. Sixth row, no matches. Is my eyes working here? No matches. Yeah. Seventh row, we got a match here. Last one, we have a match here. Okay, so this is pretty much the hard work done now. We just, wherever we got a circle, we write true, 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 true. Anywhere where there's no circle, we just go and say false, false. Okay, so that's the answer, and that's worth how many marks? 15. That's a lot of marks here. A lot of marks for something you can easily get if you're just careful. Okay, so let me just check if anyone has any questions about this truth table.
Shami, can I ask a question, please?
Sure, no problem.
With the truth table, it doesn't matter whether it's not P or is P. When you're looking at the then or the and, you use that rule. Is that correct? So if I've got not P then Q, I still look for false and true when I'm doing the truth table.
Yes, but so you mean if you not P, that later on you need to use the not P in a bigger statement. Is that what you mean?
Yes, so that truth table that you've just done, if one of those was a not P, I'm still looking for the false for the first condition and a true because of the then statement, not because of the not P. I don't know, does that make sense?
I think I get you. So, okay, let me just see if I do get you. So you mean if you
Just
have
trying to
something like
determine,
P,
yeah, just trying to
yeah,
determine how you decide whether it's true or false for the end column. You know, when you've got a negative, a not P or a not Q. Do you still apply the
okay,
false, true, false, true, false, true to determine the truth factor?
yeah, so that's a good point. So if at the end you have something like a not P and Q, then what I would recommend you do is make an extra column for not P. So after you've done that, you essentially don't have to worry about what P looks like. Whatever the not P is, it becomes a new thing by itself. And you can forget about the fact that it's a not or whatever, because it's just a variable now with trues and falses in different places. So just apply the or rule as you would for any other variable. The fact that it's not P doesn't make a difference after you've
Okay,
done
so
that
once you've
part already.
all right, so once you've got the true and false, then you just look at the true and false to determine if the first one is false, then it's true. If the second one is true, then it's true, and then anything else gives you a false.
Yeah, exactly. Exactly.
Okay. Thank you, thank you.
Okay, no problem. But again, as you guys are studying, if you have more questions and you're struggling with anything, just send me a message and I'll try and get back to you as soon as I can. Yeah, so I'll make some time because lectures will be done, so we'll have more time. I won't be as busy as I have been. Okay, so let me just check the chat if everyone is still managing. Questions, no questions yet. Okay, so again, since it's online, I don't want to waste time. We can go through other stuff while we have a few more minutes left. Maybe this question 1, we can start here. Okay, since it's only 4 minutes, let's start with the second one actually, with the matching the columns, right? Let's start here. So 2.1, let's see what it wants. A number that can be written as a whole number raised to the power of 2 is called what? Okay, so again, I wish I had time to ask you guys and be like, oh, what do you guys think? Unfortunately, I can't do that. So I have to just go with it. This is probably going to be a perfect square. right? So let me change color for that. So this is going to be, do they have that option here? Yeah, it's B, right? So let's scratch B because we're done with it. 2.2, combining the set of rational numbers with the set of irrational numbers gives, that should be the real numbers, right? Do we see that somewhere here? Do they have it, or am I talking nonsense? Integers, whole numbers, radical, tautology equations, irrational numbers.
There's a set of real numbers.
Oh yeah, sorry, thank you. There we go. That's E. My eyes are not working today. Okay, 2.3, mathematical equations that combine two expressions of equal value are known as, I feel like it should be equations, but they use the word equation in the question. Mathematical equations that combine two values, that must be equations, right? Is that here? It's I, okay. So that's obviously a typo because they give the answer in the question. But okay, we'll take it. Polynomial with three terms is known as, I want to say trinomial. Why do I feel like I'm being tested here? But anyway, it's there, so we'll take it. J. 2.5. A set that is formed when 0 is added to the numbers 1, 2, 3, and so on. So in other words, adding 0 to natural numbers will give us what? That should be whole numbers. That should be somewhere F. Okay, we see it here. Numbers that cannot be written as a ratio of two numbers. Oh, I feel like I know what they meant to say, but they didn't say it. Numbers that cannot be written as a ratio of two integers is probably what they are saying here. Very bad. Cannot be written as a ratio of two integers. The word is on the tip of my tongue. Let's see, we'll find it here. Radical, tautology, integers.
Irrational?
Irrational. Could be. I don't think that's what they mean though, but it could be. What's the word? If we can write something as a ratio of two integers, there's a word for this. It's not in my head right now. Does anyone remember this word I'm looking for? Rational numbers, right? Or cannot be. Oh, so yes, you were right. Whoever said that, thank you very much. You were right. K, irrational. There we go. Perfect. Thank you. And I think I'm going to slow down a bit now. So just try and be with me, guys. 2.7. Two sets A and B such that this rule applies. And that is said to be, there's a word against the tip of my tongue. What's the word? I think it was disjoint. There's it up here. It's A, right? Disjoint is the word. So multiple choice helps a lot, hey? 2.8. The number system used to represent numbers in a computer is known as, that must be binary. Is that here? That's C. So we'll take that one. All right, a statement which is true on the basis of its logical form alone is known as tautology. I think we did that in the last lecture. H. Studies on the way statements can interact with each other are known as propositional logic. Yeah, that's it here. Okay, so perfect. That's in time, and maybe we should stop there. So you guys can try question 1 by yourselves. And again, I'll upload the memo that I think I made a memo last year at some point. If not, I'll just make one here. It shouldn't take too long. Okay, yeah, so let me leave the floor open for questions now. Let me stop the recording in the meantime.